Welcome to lecture 40, which is on a new topic altogether, digital image processing. So, in this introductory lecture, we will understand the characteristics of the digital images and particularly the satellite images. So, let us begin the lecture. So, we have to understand first of all, what is an image. When we are talking of the image, a digital image could be any image which is taken by my camera system or taken by the satellite. So, it is a visual representation of some object. Now, this is a 2D or 3D light intensity functions where x and y denote the spatial coordinate, because this digital image consists of the pixels, and then each of that pixel has a certain coordinate system. So, we are defining the image as a function of x and y. So, one can see that in this diagram here is a tree object on the ground, and the eye is capturing that particular image. And if I could convert that particular image which is captured by my eye into some form of a signals, then I can actually represent this image digitally. So, in order to capture that, we require some kind of a imaging system now. So, this is the imaging system. Normally we call it a camera or a sensor system in remote sensing. So, here now what you have is, you have the object on the ground, and in front of the object there is a camera system. Also you have illuminating source which is illuminating the object, so that you can capture the reflectance from the object, and then this image which you are capturing from the imaging system, you are actually converting into digital image. So, my output is something like this, what you see at the end, a grid, which is, we call it the raster image. So, it is a gridded image, and the object has been shown within those grids. Now, images can be obtained from a digital camera, from a scanner, or from a satellite sensor, or it is already available maybe in my computer. So, all those are the digital images, different forms of the digital images. But if we have hard copy data, photographic data, we can do the digitization work and convert them into digital image. Because when we are doing digital image processing, this is the prerequisite. We should work on the digital image, data should be in the form of a digital, and there should be a small computing device, software which can actually do the processing of those images. So, one can see here we have a Google Earth image, the first one, the second one is the MRI scan image, and the third one is the artificially created image is there. So, there are different ways the image can be represented, but here we will talk mostly of the satellite image. So, when we are talking of the satellite image, we are collecting several samples. So, when we are talking of black and white image, there are black and white or panchromatic data, satellite data. So, we call it a one sample per point. So, at each pixel there is a one sample only. So, this we call as the grayscale or black and white images, and then the gray shade ranges from perfect black to perfect white. If we take instead of one sample at that particular pixel location, if we take 3 samples in different parts of electromagnetic spectrum, different wavelength region, red, green and blue, they are the 3 primary colors. So, if we take 3 samples at each particular location, that means we have 3 images, and we superimpose that, we can get the color image which is shown on the right side. And the advantage of these more number of sample is the more clarity. More the number of samples at a point, more clear is the image to us. As we can see, if we compare these two images visually also, the color image can provide me, I can extract more information from the color image as compared to the black and white data. And these images with more number of samples, I can create other images, I can transform into other form of the images in digital image processing and use with the original data. So, let us talk about that analog signals and the digital signals. So, we know that more information at a pixel location we have, greater is the resolution, clarity. So, we can see the object in a much more clear way if we have more and more samples which are taking place, the more information is there. And a single sample which we are taking at a particular location, this we call it a pixel. So, pixel is a term which is made from the word picture element. The short form of picture element is called pixel. So, it is called a pixel. Now, this pixel is very important when we are talking of the digital image processing. We did not talk about the pixel when we were discussing visual interpretation of the image, manual interpretation of the image. But when we have to carry out the digital image processing, digital interpretation, then this pixel and the reflectance of the pixel becomes very important to us. Now, look at the image. We have the image on the ground, and then when you have this image captured in the form of the pixel, then this becomes a two-dimensional image because it has now coordinates attached to it. As I told you, f(x), y, x and y, these are the coordinate systems of each grid locations. So, you can see in the second image now, each grid has a particular row number and the line number. Now, you can see very good image, color image of one animal here, and if I just show you the blow up of a certain part, ear of the animal, you can see pixels now. So, you can see very good image in the form of the pixels when you blow it up, because these individual pixels may not be available to you at your full resolution. Full resolution you can visualize like a very smooth image, a very smooth boundary, but the moment you see the blow up in that particular portion, now you start visualizing the pixel, and each pixel is having a color associated with it. Now, you can see the different colors here, but very smooth transition of the colors can be seen in this picture here, but here you can see that the each grid, this has a color which is associated with it, and now this color is related to the reflectance, and this is very important for us to understand and analyze in digital image processing. Now we understand that the digital image is made up of several pixels, and these pixels are arranged in the row and columns, and it is a sample of the continuous function also. Now, each pixel here is, in addition to its coordinate, it is representing the color or the brightness values. You can see here the image is shown and the image in blow up, and when you blow it up you can see the pixels. So, similarly bottom image you blow it up and then you can see the pixel. So, when you see the pixel and you see the associated color and the brightness of that picture along with its coordinate system, this is what is important to us in image processing work. So, this is the diagram which shows how the analog signal which consists of the light waves, this is moving in the form of the sine wave, and then it is converted to the varying voltage, that is what we call as the electric energy. Now, this analog signal is converted into digital signal. So, these analog signals are captured by the digital device and then converted into digital data, and this digital data now is stored in some digital media. So, this light wave, the kinetic energy which is travelling in the form of the sine wave, it is converted to the digital information. So, when it is converted to the digital information, it is working on the basis of the bit and byte. So, bit we are representing in the form of 0 and 1. So, bit is off, value is 0, bit is on, value is 1, and byte is a combination of 0 and 1. So, this is what you see here in the box, a combination of the 0 and 1. What you see is the um, byte. So, one complete line is 1 byte and 1 byte is denoting 1 pixel, and this combination of 0 and 1, because there are different combination as you can see, is actually what is giving you the color or the brightness from a pixel. So, this is a reconstructed way from the same data, but from the digital information, which is a combination of bit and byte. So, 1 byte is 1 pixel, and this unique combination of 0 and 1 will give you some kind of a digital number, that is what we say, or the reflectance value. So, this resolution, gray level resolution is important in order to understand. We have number of bits, several bits data is available. Normally we are using 8-bit data. So, 8-bit data is 2 to the power 8, and 2 to the power 8 means that there will be 256 intensity values. So, 0 is for black pixels. So, 0 to 255 will be the range in the 8-bit data, and examples are shown in the combinations of bits 0 and 1, combination of 0 and 1, and that gives me basically what is the digital number at that point. So, more is the intensity level, like in 16-bit data we have 65,536 intensity levels. So, more is the intensity level, finer will be the detail identifiable from the image. So, we would prefer the image with more number of bits or more number of the intensity levels, so that we can identify minute objects also very clearly from the images. Now, this signal or image processing, analog signal, and then analog signal is converted, transferred into the form of the image. So, there are two term here, signal processing and the image processing. So, normally the electrical engineers, they are doing that more of the signal processing. There is the discipline which is more related with them. So, it deals with the mathematics and analysis and processing of those signals. But when we are talking of the digital image processing, it deals with the signal where those analog signals have been converted into the form of the digital image. Input is digital image, output is digital image. So, there are various steps which are involved in digital image processing, and there are very large number of applications of the digital image processing, and that is what over a period of time we see that the digital image processing has overtaken signal processing, or it has become more popular, in other words, as compared to the signal processing, because of this wider acceptability and wider applications in the different domain areas. Now, I will show the gray level resolution. So, we have, for example, 3 images here. One image is showing low level information, another image showing the medium level information, and third one is showing the high level information. What does it mean? It means that this is a low bit image and this is the high bit image. One can identify much more information from the high detail data, but the storage capacity of that high detail data would be much higher as compared to the low detail data. So, we have to see that also when we are processing a large image or multiple images of different times together, we have to see this particular part also, the storage of the image, the size of the image. Now, when we are talking of the resolution, this is understood that we require high resolution data. But it is associated with the cost, and as I told you, the processing time. Now, I am showing you two picture, and it says that we want better resolution, but how much is enough? The picture on the left side, it indicate that you can see the number of the cars from this picture on the left side, but here you can identify the car from the second image. As far as the identification of the object car is concerned, there is absolutely no problem, but probably the identification of the number plate is a problem. So, you can do the both from the left image, but you cannot do the both activities from the right image. So one has to understand the application part of it, and then according to the application decide what is the optimum resolution at which the image is required to be analyzed. Now as I told you, the more the number of pixels, more will be the storage requirement, and also the resolution will also depend upon that. So pixel size, whether my pixel size is small or pixel size is very large, actually this will determine the resolution of the digital image and also the amount of information which I can extract. So as an example, I have shown the two images here of a lady on the left and the right. The left image is very clear to me because it has 82,000 pixels, same object 82,000 pixels. So naturally the size of the pixel becomes small here and the resolution becomes better. Now if I reduce that 82,000 to only 88 pixels, I want to show the same object in 88 pixels, the pixel size becomes bigger and the resolution becomes poor. Now it is very difficult actually, if I do not show you the left image, very difficult to identify what kind of object is present in my right image. So this is the difference when we are talking of a big pixel size or a small pixel size or a higher resolution or a smaller resolution. Now images can be represented, when we are talking of the digital image, it can be represented in three different forms which are shown here. One is the pictorial, in the form of the picture or the image on my computer screen. So I can display it on the screen and see individual image and then black and white image. So this is one form. The second form could be that I can convert this image into some numerical data, and what is that numerical data? You can see the matrix in the middle here, and this matrix is indicating the pixel, each pixel of a small area. This is the small area which we have taken in the form of the grey shade image. You can see each pixel with black and white images, but same pixels numerically, if I want to show what is the digital number, what is the reflectance value at that particular location, this is shown in those numerical values. So as I told you, in 8-bit image, this is the example of 8-bit image, the value will lie between 0 to 255. So here I have a value 0, the corner pixel, and value 255. So if I look at the gray shades of these digital numbers in the left image, so the corner pixel is a perfect black pixel and 255 pixel is a perfect snow white pixel. So in between there are other gray shades present. So I have different gray shades in between which are present here, but not able to identify each and every gray shades with my eye because of the limitation of the eye. But that limitation is gone when I am using a software, when I am using the capability of the software and using the reflectance values as the independent values now. Now third could be a graphical way of representing. Now if I want to see the distribution of these digital numbers in the entire image, there are certain values which are repeating also. So you can see in this matrix also that 0 is repeating at many places. So there are values which are repeating also. So that means that denotes the frequency. So one value is appearing 20 times, this frequency is 20. So if I draw on x axis, if I draw the dn value, digital number, and if I draw the frequency of occurrence of that value on y axis, I will draw a diagram which we call as the histogram. So I can represent them graphically also. So there are three ways now to represent the digital image. One is the pictorial way, another is the numerical way, and third is the graphical way of representing the information. Now these all three are very important when we want to extract the information. We will try to identify what kind of object could be present in my image, because these digital numbers which we see in the matrix, they are related to the reflectance coming out from the object. As we know from the spectral signature curve that each object will give me a different reflectance. And now also I understand that once if I can represent the image in the form of a numerical value, I can deal it mathematically. It is like a matrix. So, it is like a slightly bigger matrix, because in mathematics maybe we are dealing with the 3 by 3 matrix or a 5 by 5 matrix. But in now digital image processing, it is similar to a matrix, but a bigger matrix. I can read each and every element of this grid cell with their x and y coordinate as well as the digital number. So, I can do lot of manipulation, I can do lot of analysis with these numerical values. I can apply certain mathematical relationship and transform these values into the new values. So, I can generate a new image. So, this is how we are dealing with those numerical values. When we look at the graphical representation, so this is called the histogram, and this histogram is also very important to give us the quality of the image, which we will discuss in the next lecture. Now, when we are talking of the digital image processing, what is the process involved? We are basically either enhancing the images or processing, applying the corrections to the image or extracting the information from this image. So, what we required is we require some kind of a system and a software which can help me in identifying the pattern. We can do the pattern recognition, we can do the classification of from these satellite images and identify very specific feature. If we look back to the development, historical development of digital image processing, right from early 1920s, very first applications of digital imaging was in the newspaper industry. So, in newspaper industry the very first digital image came, which you can see here also, and this was the image which was transferred by the submarine cable between London and the New York. So, at that time whatever facilities were available, whatever the quality of the image, but that was used, digital image was used in 1920s in newspaper. And then mid to late 1920s, lot of improvements were done into the system to generate very high quality images, whether it is the new reproduction process which was based on the photographic techniques, or the number of tones were increased. So, as you can see the improved digital image is on the left side, and there are 15 tone digital image. So, as I said that 2 to the power 8 is 256 gray shades. So, similarly the number of tones were 15 now. So, you are able to identify 15 gray shades from those images. So, more the gray shades, better is the detailed information coming out from the image. So, in 1960s improvement was done in the computing technology, and with the help of the computing technology there was a change, there was a upgradation the way we were using the digital image. Then in 1964 computers were used to improve the quality of the image, and one can see the Ranger 7, the images of the moon which was taken by the Ranger 7, and this image was then enhanced with the help of the image processing methods. Then 1970s the application was done in the medical science also, because in medical applications there are X-ray, there are CT scan images, there are MRI. So, if the quality of that is not that good, how to enhance the quality so that the proper diagnosis could be carried out. In 1979 onwards, you can see that the inventors, they actually shared the Nobel Prize in the medicine also. So, application increased in the medical science, particularly invention of the tomography. So, in the invention of the tomography, as you can see the cat image which is called computerized axial tomography, and the inventors got the Nobel Prize also to develop this, and image processing was used. And if we now see 1980 onwards, we are using actually this digital image processing for vast number of activities, whether we are talking of the image enhancement, restoration of the images, or creating some artistic effects to the existing data, or maybe the medical visualization, or maybe the industrial inspection, or law enforcement or the human computer interface. So there are lot of applications which have emerged out after 1980s. But broadly, if we look at, see, in the digital image processing, what we are doing is we are doing the image processing manipulation, we are doing the image coding, and then finally we are doing the interpretation of the image. So it is not a straight away image analysis, but there are intermediate processes involved, and I will show some of these intermediate processes quickly here in this. This is a complete diagram, what are the different activities which we may like to perform on the digital image. When we have the data, maybe it is not straight away in the usable form. So maybe you like to improve the quality of the image, maybe you like to carry out some transformation of the image, you like to generate the color image from those individual images. So there are a lot of activities now which you can do after the acquisition of the image. So this is the first part, we will start from here and complete the cycle. So first one is the image acquisition part. Once the image is acquired from some digital system, let us say the satellite image, then the next would be activity after acquisition of the image. The same diagram which I have shown you, you have the raster data, you have acquired the image, and now this image, the next step would be the image enhancement. So this is the next step where the image quality is poor, maybe due to the underexpose or the overexpose, and you are not able to identify the object. So after the enhancement, improving the quality, one can see the object very clearly. So this is one of the activities which we may like to perform on the digital data, because if the image quality is poor, we do not just throw digital data. Digital data is useful in all the ways. Then image restoration, again we are dealing with the poor quality. So the image is poor quality or image is very old image, how to restore the quality of the image. So these are the image restoration technique we will like to perform, and we will like to get again the image of the original quality and carry out the interpretation from those images. Then morphological process. So there are certain enhancement, there are certain filters which we can apply to the existing data. So this is the, for example, my original image where thumb impression, so you can see the grains of the lines on the human thumb, and not very clear in original image, but when we apply the filter, when we do the morphological processing, then you can see at the end, the each and every line looks like a contour line. It's very clear, very sharp to us. So one can see the pattern of these lines very clearly after the processing. Then this is another way of enhancing the image or extracting the data. Maybe we like to do the segmentation process. So after doing that segmentation, we will like to identify the object of the interest. Once we know which is that range in which the object is falling. So this is the object segmentation which has been done. You can see a lot of shadow also in this particular image. There is a shadow, but this shadow has gone because of the segmentation process which has been used. Then the next could be the object recognition, recognizing a particular object in more than one band. So we have the images and we can just see that how the separability between the two features can be maintained, what is the specific reflectance range of that particular object, and we can actually recognize that particular object from the image data. Then representation and the description is the next part. So then how to represent and how to describe that, how to carry out the measurements. So that is the another next part of this. Then there are some part which may be the optional part, like the image compression, because this is another area in digital image processing, particularly with the availability of the big data, you have to compress the data. Then color image processing, sometimes black and white image cannot give us very good results. So we have to convert the images into some kind of a color, maybe the false color, maybe the true color, and then try to identify. So if we look at the digital image processing system, which is called DIP, if you look at the DIP systems, now the DIP system should have actually many things here. Should have the image processing hardware, image processing software. It should have the capability to storage the data, a computer attached to it, image display, taking the hard copy printout from the printer. So, several things are now associated and linked with each other. So, all of them are required and they should be probably networked together in a digital image processing system. So, these are the different application areas, but they are not the complete list. It is just the exemplary list shown here. What are the possible applications of the digital image processing? So, once we have the digital image with us, we can apply for mapping purpose. This is just one area, but apart from the mapping, you can see that meteorological, when we are talking of the seismological or automatic navigation part or the surveillance part or the microscopic part, there are actually lot of areas all around where the digital image processing is playing very important role. Now, if you look at the software, what are the software which are available to us worldwide? There are some software which are paid, commercial software. You have to procure those software, and whenever there is an upgraded version, you have to upgrade them. So, the list is again not complete. There are some exemplar list are there, but there is a website, web address is given with this list. And the idea of giving that web address is that the reader can go into the further details of these software with these sites. But these are some of the well known software, very good image processing software, but you have to pay money for that in order to carry out the image processing work. But if you do not want to pay money and you want free software, what we call as the open source software, where the source code is open, then you want free image processing software, then these are also available in plenty. So, you can see that as an exemplary list is given over here and their website is given. So, readers can actually go through the website and download these software and carry out image processing work. Maybe you cannot carry out very high level of image processing using some of these software. Maybe you have to go for the commercial software in order to carry out that work, but most of the activities can be performed with the help of the free image processing software. So, we are using the capability of the image processing software and digital image in the input, and then we are getting the very useful output for our work. So, this is all. Thank you very much.